Welcome to AI Unraveled, the podcast that demystifies frequently asked questions on artificial intelligence and keeps you up to date with the latest AI trends. Join us as we delve into groundbreaking research, innovative applications, and emerging technologies that are pushing the boundaries of AI. From the latest trends in ChatGPT and the recent merger of Google Brain and DeepMind, to the exciting developments in generative AI, we've got you covered with a comprehensive update on the ever-evolving AI landscape. In today's episode, we'll cover AI revolutionizing our understanding of animal communication, translating languages, and decoding animal vocalizations, how neural networks aid conservation efforts and assess animal emotions, the challenges of understanding meaning and validating conclusions in animal communication, flaws in logical generalization capabilities of AI models, the effectiveness of large language models in data compression, and a recommendation for the book AI Unraveled by Etienne Noumen to find answers to your AI questions. So imagine this, a new Caledonian Crow meticulously crafting a tool to fish out a tasty grub from a tree crevice. Fascinating, right? Turns out animals have some incredible communication skills that we've only just begun to understand. Take Christian Rutz, a behavioral ecologist who has spent his career studying the new Caledonian Crow. He noticed that these birds live in complex social groups and actually pass on tool-making techniques to their offspring. But here's the kicker. Different crow groups have their own unique vocalizations. Rutz wondered if these dialects could explain the cultural differences in tool-making among the groups. That's where artificial intelligence, AI, comes in. With recent advancements, we're on the brink of major breakthroughs in understanding animal communication. AI can help us decipher animal vocalizations, like the calls of crows. A group called the Earth Species Project is using machine learning models to analyze data collected from various species. And the Project Cetacean Translation Initiative is specifically focused on understanding the vocalizations of sperm whales. Decoding these vocalizations not only aids conservation and welfare efforts, but it also has a profound impact on us. It's like when the telescope was invented, we realized Earth wasn't the center of the universe. AI has the potential to reshape our understanding of animals and our place in the world. Scientists like Shane Gero are already using AI to decode the complex vocalizations of sperm whales. By analyzing patterns of sound called codas, Gero and his team have identified individual whales with 99% accuracy. And now they're aiming to train a computer to speak whale by recording the vocalizations of Dominica's resident whales around the clock. AI is opening up a whole new world of possibilities for understanding animal communication, and it's truly mind-blowing. These tools are changing the way we see ourselves in relation to everything around us. Artificial intelligence, AI, has made significant progress in recent years, enabling us to delve into the world of animal communication like never before. With the availability of cheaper sensors and advancements in technology such as hydrophones, biologgers, and drones, the amount of data gathered from animals has exploded. However, this deluge of data is challenging for biologists to manually analyze efficiently. This is where AI comes in. AI models, particularly large language models like ChatGPT, thrive on vast amounts of information. For instance, ChatGPT-3 was trained on approximately 45 terabytes of text data, a substantial portion of the entire Library of Congress. In the early days, humans had to classify a significant part of this data with labels, essentially teaching the machines what was important. Nevertheless, the next generation of models have advanced to the point where they can self-supervise. They automatically learn the essential elements and create algorithms to predict what words will follow in a sequence. A breakthrough in translation occurred in 2017 when researchers found a way to translate between human languages without relying on a Rosetta Stone. This discovery involved transforming the semantic relations between words into geometric ones. Machine learning models can now translate unknown human languages by aligning shapes. By analyzing the frequency of words appearing in proximity to each other, models accurately predict what will follow. This suggests that there is an underlying structure that unites languages, opening doors for decoding new languages using machine learning techniques. In 2020, natural language processing took another step forward by considering everything as a language. For example, DALL-E 2, an AI system capable of generating realistic images from verbal descriptions, maps the shapes that represent text to those that represent images with remarkable accuracy. This kind of multimodal analysis is likely to be crucial in translating animal communication, as many animals use different modes of communication concurrently, much like humans use body language alongside speech. By considering the actions immediately before, during, or after sounds, we can better understand the context and meaning behind an animal's communication. Machine learning models trained with the right data could help decode these behaviors and potentially uncover new patterns. An example of AI-powered analysis already in use is Merlin, a free app developed by the Cornell Lab of Ornithology. Merlin uses AI to identify bird species. Users can record bird sounds, which Merlin then converts into a spectrogram, a visual representation of the volume, pitch, and duration of the call. By comparing the user's recording with its trained audio library and cross-referencing with the global database of observations called eBird, Merlin can accurately identify more than 1,000 bird species. This demonstrates the potential for AI to assist in understanding animal communication on a broader scale. The ability of AI to process and analyze large amounts of data can greatly aid in deciphering complex animal communication patterns. In a study published in Nature Communications, scientists reported that machine learning models unearthed previously unrecognized differences in zebra finch songs that elicit attention from females during mate selection. Females prefer partners that sing similar to the birds they grew up with, and AI models were able to identify this pattern. Such findings highlight the potential for AI to discover novel information hidden within animal communication data. AI's impact on animal communication research goes beyond language translation and species identification. It has the potential to detect and understand the nuances of animal behavior by examining the context in which communication occurs. For instance, AI models trained to recognize patterns in body language and gestures, along with vocalizations, could reveal valuable insights into how animals communicate and interact with each other. With the rapid advancements in AI and the increasing availability of data, the future of animal communication research looks promising. By harnessing the power of AI, scientists can explore, decode, and understand the rich world of animal communication in ways that were previously unimaginable. It is an exciting frontier that opens up a new realm of knowledge and understanding about our fellow creatures with whom we share this planet. But the world can be a noisy place with so many sounds overlapping and mingling together. It's like trying to pick out one specific bird's song in the middle of a bustling cacophony. And the same goes for other animals like whales. It has always been a challenge for scientists to isolate and identify individual animal speakers amidst all the chaos. They call it the cocktail party problem, and it has always hindered our ability to process and understand animal vocalizations. But here's the exciting part. In 2021, the Earth Species Project came up with a groundbreaking solution. They developed a neural network that can untangle and separate overlapping animal sounds, like individual tracks in a music recording. And you know what's even better? They released the code for free as an open source project. This means that anyone can use this technology to filter out background noise like car honks and focus on the specific sounds they want to study. It's a game changer. Let me explain how it works. This neural network creates a visual representation of the animal sounds, like a spectrogram or a waveform. It then uses this representation to determine which pixel corresponds to which speaker. It's like a magic trick for audio processing. Now researchers can finally distinguish between different animals in a chorus of sounds and understand each speaker individually. And that's not all. The Earth Species Project has been on fire lately. They also developed what they call a foundational model. This model can automatically detect and classify patterns in massive datasets. Imagine the possibilities. It can help scientists analyze and make sense of the immense amount of information contained in animal vocalizations. It's like a revolutionary tool for unlocking the secrets hidden in the animal kingdom's communication systems. Let me give you an example. Have you heard of the new Caledonian Crows? They are renowned for their remarkable toolmaking skills. But did you know that they also have unique vocalizations specific to different regions? It's fascinating. And with the help of AI, we might one day decipher and understand the meaning of these vocalizations. Just imagine the insights we could gain into the lives of these intelligent creatures. But it's not just about unraveling the mysteries of nature. These tools have real practical value as well. Think about endangered species, like the Hawaiian crow or the alala, as it is known locally. These birds went extinct in the wild a few decades ago, and efforts have been made to conserve and reintroduce them through breeding programs. One of the researchers involved in studying the new Caledonian crows, Rutz, is now collaborating with the Earth Species Project to delve into the Hawaiian crow's vocalizations. He wants to create an inventory of the vocalizations used by the captive birds and compare them to historical recordings of the last wild Hawaiian crows. By doing so, he hopes to uncover whether there have been any significant changes in their repertoire while in captivity. This knowledge could aid in understanding why reintroducing the crow to its natural habitat has been so challenging. Now let's take a moment to talk about our beloved pets. For the longest time, animal behaviorists haven't paid much attention to domestic pets, but that is changing. Kon Slobodchikov, the author of Chasing Dr. Dolittle, Learning the Language of Animals, has been studying prairie dogs for years and has discovered the complexity of their communication through calls. This understanding led him to become a behavioral consultant for dogs, as he realized that many owners misinterpret their pets' signals. You see, our furry friends don't just rely on barks. They communicate through various signals, including body language. And unfortunately, we often miss out on these cues because we are fixated on sound as the primary means of communication. But Slobodchikov is working on an AI model that can help translate a dog's facial expressions and barks for their owners. He firmly believes that animals have their own thoughts, hopes, and even dreams. And with the help of AI, we might just be able to understand them better and strengthen the bond between humans and our four-legged companions. But the potential impact of this technology extends beyond companion animals. Farm animals, for instance, could greatly benefit from a deeper understanding of their emotions. Elodie F. Briefer, an associate professor in animal behavior, has been studying pig vocalizations and their emotional states. She trained an algorithm using thousands of pig sounds to predict whether the animals were experiencing positive or negative emotions. This incredible feat demonstrates the potential for AI and machine learning to improve animal welfare by helping us comprehend their feelings and tailor better care. So you see, these developments in AI and machine learning aren't just for the sake of research. They have practical applications that can make a difference in the world. Whether it's protecting endangered species, understanding our pets better, or ensuring the welfare of farm animals, these tools offer us a glimpse into the rich and complex world of animal communication. And who knows what other surprises await us as researchers continue to explore and unlock the secrets of the animal kingdom. Language models are incredibly proficient at identifying patterns, but they do not possess the ability to decipher meaning or always make accurate conclusions. This lack of understanding makes it difficult for AI experts to validate the algorithm's results. Benjamin Hoffman, formerly involved in the development of the Merlin app and currently a member of the Earth Species Project, states that one of the biggest challenges scientists face is how to learn from the discoveries made by these models. Hoffman explains that the choices made in machine learning have a direct impact on the scientific questions that can be asked. For example, Merlin Sound ID can identify which birds are present, aiding in ecological research. However, it cannot answer questions about bird behavior, such as the types of calls made during interactions with potential mates. Understanding animal communication requires comprehending what the computer is doing when learning how to interpret it. Director Daniela Roos, from the Massachusetts Institute of Technology, Computer Science, and Artificial Intelligence Laboratory, is excited about the possibilities of studying animal communication with the help of machine learning. Russ previously developed remote-controlled robots for whale behavior research, collaborating with biologist Roger Payne, known for popularizing the Save the Whales movement. With advancements in underwater monitoring sensors and improved AI models for data analysis, the two fields can now be combined. At the Earth Species Project, Rutz initially focused on isolating sperm whale clicks from the ocean's background noise. Sperm whale vocalizations resemble binary code in the structure of representing information, but they are more intricate than that. Rutz used machine learning to analyze how these clicks combine into codas, searching for patterns and sequences. By understanding these building blocks, they can begin studying the foundational components of the language and determining if the sperm whale lexicon possesses language-like properties. It is worth noting that understanding the structure of a language is not necessary for speaking it. AI can now mimic patterns and intonations of human speech after being trained with just 3 seconds of audio. Raskin, a project member, predicts that within the next year or two, this capability will extend to animal communication, making it easier for researchers to infer the meaning behind animal vocalizations. The Earth Species Project plans to conduct playback experiments in collaboration with biologists, involving playing artificially generated calls to animals in a laboratory setting and observing their responses. Raskin confidently asserts that soon they will be able to pass the Turing test with animals such as zebra finches, crows, and whales. This test determines if an animal can differentiate between conversations with a machine or a member of its own species. However, ethical concerns arise with the potential misuse of this technology, such as precision fishing or poaching endangered animals. As of now, nonprofit organizations like the Earth Species Project lead the field of animal communication research. These organizations prioritize open-source data and model sharing, driven by scientists passionate about the animals they study. However, the landscape may change as profit-driven entities enter the scene. Guidelines and legislative frameworks are necessary to ensure responsible development and usage of this technology. Designing a whale chatbot, like the aspirations of Project Cetacean, entails more than replicating the clicks and whistles of sperm whales. It requires understanding the animal's experience. Humans share many basic forms of communication with other animals, such as parent-offspring interactions. Both human and animal vocal expressions show similarities in development. The existence and conveyance of language-like qualities in animal communication are a subject of debate, with critics cautioning against imposing human linguistic rules on it. George Happ and Christy Juncker, retired scientists who observed a pair of wild sandhill cranes over 2 decades, offer insight into the behavior of these birds. They explain how, after the death of one of their colts, the surviving members engaged in what could be interpreted as mourning behavior. While critics may argue that squarely attributing emotions to animals lacking human capabilities is imprecise, the evidence from close observation suggests otherwise. The pain of losing a loved one is a universal experience, and the ability to relate to it may be the true value of any language. Juncker and Happ eagerly anticipated the return of Millie and Roy, a crane pair that frequented their home every spring. Unfortunately, they did not appear in 2017. Despite the loss, a new crane pair nested and successfully raised their colts, signifying the continuation of life's cycles. Juncker remarks that, rather than just observing nature, humans are an integral part of it. The understanding and translation of animal communication necessitate new tools and the ability to transcend human biases and expectations. Recognizing that each species has its own unique experiences and perspectives is vital for comprehensive communication with animals. So, there's some interesting research that has just come out showing a bit of a flaw in how AI models are trained. It turns out that training these models on statements like A is B doesn't actually enable them to figure out that B is A without further training. In other words, they struggle with generalization. To explain a bit further, let's say you teach one of these models that Olaf Scholz was the 9th chancellor. Now, you might expect it to be able to deduce the opposite statement, right? Well, it turns out that's not the case. Even models with billions of parameters fall short in this aspect. Researchers conducted some tests to uncover this deficiency. They used both fictional examples like X is Y statements and reverse questions, as well as real celebrity examples and their reversals. The results were quite telling. The success rate dropped from 79% for forward statements to just 33% for the reverse ones. If you're interested in diving deeper, you can check out the full 18-page paper on this subject. Also, if you're a bit of a coding enthusiast, you can find the code for this research on GitHub. In a nutshell, This study exposed what the researchers are calling the reversal curse. It highlights the fact that these models struggle to infer reversed statements, which in turn underscores the limitations in their logical generalization capabilities. Quite fascinating stuff, don't you think? Have you ever wondered how language modeling is related to compression? Well, DeepMind and Meta have conducted some fascinating research on this very topic. They have been exploring the compression capabilities of large language models, LLMs, and the results are quite impressive. In the past few years, the machine learning community has been all about creating bigger and more powerful self-supervised models. These LLMs have proven to have remarkable predictive abilities, making them excellent candidates for strong compressors. The research delves into the connection between compression and prediction. DeepMind and Meta have found that foundation models, which are primarily trained on text, possess remarkable in-context learning capabilities that enable them to be versatile compressors. To put it into perspective, a model called Chinchilla 70B achieved compression rates of 43.4% on ImageNet patches and 16.4% on library speech samples. What's particularly interesting is that these rates exceed those achieved by domain-specific compressors, such as PNG or FLAC. So, by leveraging the power of language modeling, these models are able to compress data more effectively in certain domains. This research opens up exciting possibilities for leveraging the compressive power of language models in various applications. It highlights the potential of machine learning in discovering unconventional solutions to classic problems such as compression. Hey there! If you've got a burning curiosity about artificial intelligence, I've got just the book for you. It's called AI Unraveled, Demystifying Frequently Asked Questions on Artificial Intelligence by Etienne Noumen. Trust me, it's an absolute essential for anyone looking to dive deeper into the world of AI. What's great about this book is that it's designed to unravel all those burning questions you might have about artificial intelligence. Whether you're a complete beginner or you've already got some knowledge under your belt, AI Unraveled has got you covered. And the best part? You can get your hands on a copy right now. Yep, it's available at popular platforms like Apple, Google, and Amazon. So, no matter where you prefer to do your shopping or reading, you can pick up a copy of this fantastic book in just a few clicks. So, if you're eager to expand your understanding of artificial intelligence, don't wait any longer. Head over to Apple, Google, or Amazon and grab yourself a copy of AI Unraveled today. Trust me, you won't regret it. In this episode, we explored how AI has the potential to revolutionize our understanding of animal communication, decode their vocalizations, analyze and translate languages, aid in conservation efforts, assess animal emotions, and even enable communication with animals, all while acknowledging the challenges in understanding meaning, ethical concerns, and responsible use, as well as the flaws in logical generalization capabilities of AI models. Plus, don't forget to grab AI Unraveled by Etienne Noumen to dive deeper into the world of artificial intelligence. Join us next time on AI Unraveled as we continue to demystify frequently asked questions on artificial intelligence and bring you the latest trends in AI, including ChatGPT advancements and the exciting collaboration between Google Brain and DeepMind. Stay informed, stay curious, and don't forget to subscribe for more.